Welcome to classes on inorganic chemistry. Today's class is on structures of atom. It is higher secondary first year. So structures of atom I have done only previously. I have taken two classes. It is probably third class on structures of atom. Today I will do de Broglie's hypothesis. Let me explain some of the facts regarding de Broglie's hypothesis on which he has given some mathematical formulations, and this is based on the fact that light particle has particle as well as light has particle as well as wave character. So also all the matter has wave and particle character. As all the matters have wave and particle character, so an electron behaves as both wave and particle character. So it's a very simple things that we know that light particle has wave nature. So also it is proved that it has a particle nature. So all the matters have both wave and particle character. As such, electron behaves as both wave and particle nature. So there are two things related with the subatomic particle like electron, that it has wave in nature. When it moves along with the wave. It is very simple to understand, but does it have the particle character? It cannot be easily understood. So he proposed or suggested that electron has both particle and wave character. He has mentioned these two. Hence, this is also termed as dual nature of subatomic particle like electron. Each and every particle has dual nature, and so also electron has wave as well as particle nature. This dual nature was proposed by de Broglie, and hence it is termed as de Broglie hypothesis. So what is its mathematical formulation? Very simple mathematical formulation is lambda is equal to h by mb, or lambda is equal to h by p, where p is equal to momentum, that is mb, while lambda is equal to wavelength of subatomic particle like electron, and h is a Planck constant. It is known to you 6.62 into 10 to the minus 34 joule second, and mb is equal to mass into velocity is the momentum. So lambda is equal to h by p. So also lambda is inversely proportional to momentum of a particle. If the particle has momentum more, its wavelength is less, and vice versa. On the other hand, if a particle has more mass, it has more lambda, less lambda. If particle has more momentum, it has less lambda, and vice versa wavelength. So this is the mathematical formulation of de Broglie's hypothesis or dual nature proposed by de Broglie. Now you may think that how this formula h by mb come into force, or how it is derived. In very simple way he derived it. He has taken two things. E is equal to h nu and Einstein's relation, E is equal to mc square. Combining these two, E and E are same. H nu is equal to mc square, where h nu is equal to c by lambda is equal to mc square. So this two cancels out. H by lambda is equal to mc, or you replace these two, h by mc is equal to lambda. M equal to mass and c is the velocity, and same mass and velocity, lambda is equal to h by mv. So lambda is equal to m by mc. This is the relation as to how it is derived. So this is all about de Broglie's hypothesis. Now this formula can be taken in different form. We know lambda is equal to h by mv, or we know kinetic energy half mv square equal to kinetic energy, or multiplying both sides by m square b square is equal to me, or m square b square is equal to twice me, or mb is equal to root over twice me. So by placing this value here, we can write lambda is equal to h by, in place of mb we can put root over twice b, and this is a very important formula which is very often applied in solving out different problems which very often asked in entrance exam. Now Heisenberg's uncertainty principle. Again, it is a very important principle, was proposed by Heisenberg, and this is termed as Heisenberg's uncertainty principle. And this is very important in the sense that when subatomic particle like electron moves around nucleus, so two things is associated with this one. One is its mass, and one is its velocity, and other its position. So Heisenberg proposed that it is impossible to measure simultaneously the velocity or momentum of a subatomic particle and its position. This suggestion, or this is termed as Heisenberg's uncertainty principle. What does it mean? That is, at the same time, it is not possible to measure the position and at that position the momentum or velocity of a subatomic particle. If you can precisely measure the position of this subatomic particle which is revolving in a circular path, if you by any means measure its position, then at that point of time when position is measured with accuracy, it jumps to the other position. At that point of time, at that position, its velocity cannot be measured. If you then measure the velocity, the electron will move away to some other places. Means at the same time, its momentum or velocity and position cannot be measured. If you measured any one term, say position or momentum, with certainty, then it tends the measurement of velocity or momentum to calculate. So measuring of one thing, position, tends to measuring in huge uncertainty in its momentum, or measuring in calculating its momentum or velocity at certain time, tends uncertainty in measurements of in position. So if one thing is measured, it adds the uncertainty in measurement of other thing, and vice versa. And this proposition was termed Heisenberg's uncertainty principle. So it is impossible, I am telling, I am not writing, it is impossible to measure simultaneously the exact position or momentum of a subatomic particle at same time. If one term is measured with certainty, that tends the uncertainty to measure other term and vice versa. And mathematically, it is told, it is said that del x and del mb is greater than equal to h by 4 pi, where del x is the position, change in position, and del mb is the change of momentum, which is greater than or equal to h by 4 pi. H is Planck constant, 4 is constant, pi is constant. Am I right? So, or you can write x is equal to, take it out, and h by 4 pi, or you can write del x del v is greater than equal to 1 by 4 pi m. This is another formulations or mathematical formulations of Heisenberg's uncertainty principle. In short, I am telling what is the reason, that is calculating in one thing position tends to or adds the uncertainty measurement of its momentum, or if you want to measure the momentum of a subatomic particle with a great certainty, it tends a great uncertainty in measure of del x at that time, at that instant of time, because subatomic particle electron is a very tiniest particle, and it requires, when you want to view the electron in order to find, say, its position, if you want to view this one with a huge tunnel microscope, say TUNNEL tunnel microscopes, so the energy to view its or to locate its position, I need to view it. Regarding when you want to view it, some amount of energy from the instrument will fall upon this one, and when you measure, say, its position with looking through the strongest microscope, so the energy fallen upon this one, it's as soon as it gets this energy, is immediately jumps to its another position. So if you can measure exactly the position, so instantly on releasing some amount of energy towards viewing of this one, it jumps to the other position. So it's not possible for you to measure the momentum at this position. You can measure in other position this momentum. So two things at same point, at same time, cannot be measured for some particle, and that is given by Heisenberg, and that principle is given by Heisenberg's uncertainty. So another concept is very often mentioned in your book and very often asked sometimes in very higher exams, entrance exam. So Schrodinger wave equation. Schrodinger wave equation actually is an equation with the help of which we can get a lot of things. Whenever we solve out this equation, I will come across with this one. When we will solve out this equation, we will get quantum numbers values, excess spin quantum number. So what is Schrodinger wave equation, and what is the main basis upon which Schrodinger gave an equation? The basis is dual nature of electron. Number one, dual nature of electron. Number two, so in a very simple way, just I am telling you, that is, it is based upon dual nature of the subatomic particle like electrons, and electron is assumed in three-dimensional space with electric field of positively charged nucleus. Number three, the possibility of finding electron at certain time is given by the equation d2 psi d square plus d2 psi dy square d2 psi dy square 8 pi square m by h e minus b psi into 0. Now this is the probability equation of Schrodinger wave equation given by Schrodinger, and basing upon which you will able to find the possibility of finding the electron, means it will give the electron cloud density or it will give the concept of orbital. But the concept of orbital is not the same as the concept of orbital given by Bohr. Bohr has given concept of orbital in a circular manner. It is a two-dimensional space x and y. But here the space of electron, the position or location of electron is mentioned in the three dimension, means x, y and z axis. Means the wave of the electron is in a three-dimensional space in x and y direction, and the possibility of finding that electron in a maximum possibility of finding that electron in the space which is nothing but orbital. It is a, what is orbital now? According to Schrodinger wave equation, it is a three-dimensional space where there is maximum possibility of finding the electron, is called orbital. But it is not the same as the orbital as described by Bohr, when it is told that it is a two-dimensional space in a fixed path. It is not fixed path, it is a spherical ball like it with the s orbital, and from the center is the nil possibility around the all equal distance. If you plot the dot at different time of time, you will get the possibility of this electron, and this possibility, when you will take it at one time, you will find it just a spherical ball or dumbbell shape or this and that. So orbital is nothing but the possibility, maximum possibility of finding the electron in a three-dimensional space, maybe spherical, maybe dumbbell, maybe double dumbbell. So that orbital is not the same as the orbit as described by the Bohr. Now you may think, what is D? What is psi? Psi is the wave amplitude or wave function. What is xyz? Xyz spatial coordinate, xyz three-dimensional spatial coordinate, Now what is H? Is the Planck constant. What is E? E is the total energy. What is B? B is the potential energy. And this is the relation d2 psi d square plus d psi dy square d2 psi dy square 8 pi square m by h. M equal to mass of the electron, E is equal to total energy, B is equal to potential energy, lambda is equal to 0. It is the Schrodinger wave equation. Psi square. What is psi? So this is the very important things. Actually psi doesn't have the meaning. There is the meaningful term is the psi square. Psi is nothing but the wave functions of the amplitudes of the wave of the electron, and psi square is nothing but the density. It is the very significant term. Psi square is the proportional to the finding the electron in a space. It is directly proportional to finding the electron in a space. It has the significance. It doesn't have any significance. Psi square gives the electron density, that is the probability of finding the electron in a space. Number 4, on solving the Schrodinger wave equation, we get the sets of quantum numbers which gives information like distance, energy or orientation or shapes of the orbital. So what does next we will come with the quantum number. What does this quantum number arise out? We don't know. Actually these are nothing but the result of the solution of the Schrodinger wave equation except spin quantum number. All the quantum numbers value has been derived on solution, all solving out the Schrodinger wave equation which I have already mentioned. And this on solving out the Schrodinger wave equations, we get the sets of quantum number which specify the electrons, so also the orbitals, the shapes, energy and distance, and the orientations of the electron orbital and its electron. So all this information can be gathered out of the set of quantum number which can be derived out of the solution of the Schrodinger wave equations. So the Schrodinger wave equation is very important use, and will not show you the solution of Schrodinger wave equation. It is a bit hard and it is out of the scope of your class, and just we will directly go to the sets of quantum numbers. How I will explain all this. So one of the very important things maximum of you do not know. Everybody of you know that there are 4 quantum numbers. One is, I will discuss, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So what does this quantum number signify, or what is the meaning of this signify? What is the meaning of these quantum numbers, and how this quantum numbers is used, or in which way it is used, and what are the things to be described with the help of this quantum number? It is not known to you. Maximum of you don't know, I assure. That is each orbital in an atom is specified by 3 sets of quantum number. The specification of orbital, I will come a bit later on. Shell, subshell, orbital. Don't be nervous, I will explain. So the information regarding the specification regarding the orbital, its shapes, its energy, its momentum, its distance, its size, its orientation, orbital shape, size, regarding the specification of orbital, 3 quantum numbers are required for specification: NLM, principal quantum number, azimuthal quantum, magnetic quantum number. But 4 quantum numbers, just the spin quantum number, if you add, and that including the spin quantum number L, N, M, and S, is required for the specification of electron in an atom. So 4 quantum numbers are not at all is used to specify the orbital. 3 quantum numbers are used to specify the orbital: its shape, its size, its distance, its energy, its orientation, etc. The 3 quantum numbers are required to specify the orbital, and the last, the spin quantum number, which is for electron, the specification of electron, we need 4 quantum number to describe it. One is principal, azimuthal, magnetic, and spin quantum number. On the amid of my discussions, once again I am telling that the sets of 4 quantum numbers is derived from Schrodinger wave equation is not true. The Schrodinger wave equation, the sets of 3 quantum numbers are derived means principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number is not the result of the solution of Schrodinger wave equation. Mind that very often this question is asked in the entrance exam. So we have understood what is quantum number. Quantum numbers are those numbers with the help of which we can get the specification orbital as well as the electron in it. So there are 4 quantum numbers. Number 1 is principal quantum number. Principal quantum number. It is designated by small n. It is designated by small n. It is given by, was given by Bohr. Its value is equal to 1 to 3 dot dot dot. It gives information distance of orbital from nucleus, that is, it gives size of orbital, it gives information So I have given you a lots of information regarding the principal quantum number. What is principal quantum number? It is the quantum number which is designated by the letter small n, number 1. And this quantum number was proposed first by Bohr, and its value is equal to n 1, 2, 3, 4. It is very important things I have written is in double. So its value is 1, 2, 3, and its what is its significance? It gives distance of orbital from the nucleus. So 1s, twice s, twice 1s, twice s, twice p, thrice s, thrice p means from the nucleus. If the nucleus is like this, here it is distance of 1s, it is distance of 2s, it is distance of 2p. So 1, that 1 is its principal quantum number, 2 is principal quantum number, this quantum number, principal quantum number, this quantum number also gives the distance of the orbital from the nucleus, and also it gives the size of the orbital. 1s, the size is 2s is greater than 3s is greater than 2, like this. The orbital size are in this way. So it's also this quantum number signifies the size of orbital. Also it signifies energy of orbital, the energy in increasing order. 1s is greater than 2s is greater than 2p is greater than thrice s is greater than thrice p. It is in increasing order. So it gives all the information. It is 1, and it given by Bohr. It is 1, 2, 3. Distance of orbital from the nucleus, size of the orbital, energy of the orbital. Used to calculate the momentum. What is momentum? mvr is equal to n into h by twice pi. That n is also used in calculating the angular momentum of electron. You have got in Bohr's theory, mvr is equal to n, and that n is used in calculating the angular momentum of the electron. So these are the simple concept on the principal quantum number. So now so these are the very important, this quantum number is very important, the azimuthal quantum number. It is designated by small l. It was given by Sommerfeld, and its value is very important, 0 to n minus 1. N is the principal quantum number. The value of n is equal to 0, 1, 2 dot dot dot. So it is linked to the value of n. The value of l is equal to 0 to n minus 1. Am I right? Maximum number of electron in a subshell is equal to twice into 2l plus 1. And also very important term is the value of L is related to the subshell. I am coming to subshell. If the value of L is equal to 0, the subshell is S. If L is equal to 1, it is P. L is equal to 2, it is D. L is equal to 3, it is F. Am I right? So if you are asked to find the number of electron in the subshell, say if it is S, subshell is S, how much electron is there, or what is the possibility of maximum electron in it? So for S, L is equal to 0. You put the value of L equal to 0. 2 into 0 equal to 0 equal to 1. 2 1 are 2. So number of maximum electron of S orbital is equal to 2. If you are asked to find out the maximum orbital in P subshell, electron in P subshell, we can calculate from this one. For P, the value of L is equal to 1. So you put 2 into 1, 2 1 are 2 and 1 3, 3 2 are 6. So number of electron, maximum electron in P subshell is equal to C. 6. If you are asked to find out the maximum number of electron to be accommodated in D subshell, and for D the value of L is equal to 2, you put the value of L is equal to 2, 2 to the 4, 4 1 5, 5 to the 10, so D is equal to 10, so also you will find F is equal to 14. So you can calculate the maximum number of the electron to be accommodated in the subshell sp, d and f orbital by the formula 2 into twice L plus 1. But the individual value of L is dependent upon the value of n, so 0 to n minus n. Now, what is the main thing L will determine? It determines the subshells in which the electron belong. It will give you whether the electron will belong to S, whether electron will belong to P, whether S electron is belong to D. It will give you the information in which subshell the electron belongs. Say, if the value of L, we are dealing with the azimuthal quantum number. If the value of L is equal to 0, the subshell is S, that electron is in S subshell. If the value of L is equal to 1, it is P orbital, P subshell, that is the electron belongs to P subshell. That is the value azimuthal quantum number determine the subshell in which the electron belong. In which subshell electron belong, with the help of the value of L we can determine. Now it tells about the shape of subshell. It is very important. What is the shape of subshell? Subshells are S, P, D and F. Am I right? So if subshell, what is the shape? We know it is shape. It is spherical, it is dumbbell, it is dumbbell, it is very critical and very complicated one. So regarding the shape, what will be its shape, we will discuss about this one a bit later. This quantum number will give it the information. This is the significance of this quantum number, very important significance. It is related to shape of the orbital, dumbbell, spherical, double dumbbell. And this quantum number for entrance exam is very important. The angular momentum, we know mvr is equal to root over L into L plus 1 into h by twice pi. So if we want to find out the angular momentum of the electron revolving in subshell, so we require the value of L. So formula is mvr is equal to root over L into L plus 1 into h by 4 pi. So say if the orbital is S, so if you are asked what is the angular momentum of electron moving in the S orbital, for S orbital L is equal to 0. So you put the value of L 0, 0, 0, 0, whole thing is 0. That is angular momentum for electron in S orbital is 0. But it is a very complicated thing. If angular momentum is 0, that is either mass is 0 or velocity is 0 or radius is 0, but nothing is possible. If mass is 0, electron does not exist. If velocity is 0, electron should not move. If r is 0, electron should be in the nucleus, atom will not exist. But how can the angular momentum of electron in S orbital is 0? Because for 0 L is equal to 0, if I get chance, I will explain. It's a very important thing. Very often you will be confused. How the angular momentum of electron in S orbital is equal to 0. On the other hand, I am not concerned with the result or the explanation of this thing. Very critical things I will explain if I get time. But here I am telling that it helps in finding out the angular momentum of electron in S, P, D and F subshell with the help of the formula mvr equal to L into L plus 1 into h by twice pi. So these are the some important information we can get from azimuthal quantum number. Very simple things I am just here explaining. Magnetic quantum number is designated by M, and it was proposed by Zeeman, a scientist Zeeman, and it gives orientation of the orbital. Orientation, I am not telling subshell, I am telling orbital. It gives orbital. I am coming subshell, shell, subshell, orbital a bit later on. And its value very important, and value again is depend on the value of L minus L2 plus L, and total value, how much value of this magnetic quantum number, it will given by 2L plus 1. Say I am taking one example. The value of L is equal to 2. You are asked to find out the value of M. So M is equal to minus L2 plus L. That is minus 2, minus 1, 0, 1, plus 2. These are the value of M. How much value? How many value? 1, 2, 3, 4, 5. So if I are asked to how many value will be calculated from this one? What is the value of L? L is equal to 2. 2 into 2 plus 1, you are getting 5 values, and you are getting 1, 2, 3, 4, 4. Number of values of M is equal to twice L plus 1. What is the value of L? If L is equal to 2, it will have 5 values. And what are the different 5 values? It will be given by minus L2 plus L. That is minus 2, 2 plus 2, minus 2, minus 1, 0 plus 1 plus 2 means 5 value. Now, these are the value regarding the numerical value we are talking about. But what does it means? It means orientation. What does orientation means? What does orientation means? Say if L is equal to 0, M is equal to the value of M is related to value of L. So I told you the value of M is equal to minus L to plus L, means minus 0 to plus 0, that is M is equal to 0. What does orientation means? Orientation means its spatial arrangement. Here orientation is 0, means it doesn't have an orientation. This orbital has no orientation. If L is equal to 2, L is equal to 2, so M is equal to minus 2, minus 1, 0, plus 1, plus 2. 5 values. So if L is equal to 2, means it has 5 values, means it has 5 orientation. And 5 orientation will explain it has d orbital. D orbital has 5 orientation. And if L is equal to 1, means M is equal to minus 1, 0 to plus 1. This 3 value indicates, means it has 3 orientation. What does 3 orientation means? If L is equal to 1, if L is equal to 0, S orbital. If L is equal to 1, it is P orbit. It is P subshell. So P subshell, and this P subshell has 3 orientation. So value of M, which is related to value of L, and this gives value of L. 1 means P subshell, and this 3 value indicates that it has 3 orientation, means P is dumbbell. It may be X, Z, Y. So maybe it may be in X direction, it may be in Y direction, it may be in Z direction. That is called Px, that is called Py, that is called Pz. That is the P orbital, which is dumbbell in shape, single dumbbell in shape, may or is having 3 orientation in the space, maybe in x-axis, maybe in y-axis, maybe in z-axis, and this 3 orientation is designated by the value of magnetic quantum number. So magnetic quantum number of values of magnetic quantum number gives its orientation of the subshell orbital in the space. So if L is equal to 0, M is equal to 0, means L is equal to 0 means S subshell means m is equal to 0 means it does not have any orientation, means it is spherical. We will discuss a bit later regarding the shape of different orbital, then we'll explain it in elaborate. So this is regarding the magnetic quantum number. The last one is the spin quantum number, which is very simple and nothing to explain more. Spin quantum number, it is designated by S, means when electron moves in an orbital, so the spin of the electron must be in plus half and in minus half direction. Plus minus half means if it is in clockwise direction, one electron, and other electron will be in anti-clockwise direction. So if it is clockwise means plus half, if it is in anti-clockwise, electrons moves in spins way. If it is spin in clockwise direction, plus half, it is spin in anti-clockwise direction, minus half. So these are the value of permitted value of the spin, plus half, minus half, which is not the result of solution of the Schrodinger wave equation. So these are in short the information regarding quantum numbers. Now, before going to shape, now let us tell about shell, subshell, orbital. So before understanding shell, subshell and orbital, let us first go to the metric level concept. What is K shell? When L is equal to 1, it gives you K shell. When N is equal to 2, it gives L shell. N is equal to 3, it gives M shell. Let us take N is equal to 3, means it is M shell. It is M shell. Now, this is in a very simple the shape subshell. Shell is in the, say, in a train is shell. Coach, its coach, subshell. Its seat, orbital, each passenger electrons. Very simple. In a bigger train shell, all the coaches of the train are subshells, and inside each coach, each seat, SEAT, seat are orbitals, and in the seat all the passengers are electrons. So shell is in a bigger sense. Each shell consists of subshell, M shell. There is M, N is equal to 3. In this M shell, K shell is consist of only one subshell, S. L shell is N is equal to 2, consists of 2 subshell, S and P. N is equal to 3, consists of 3 subshell, S, P, D. So if you take M shell, we are getting 3 subshell. The value of M, N is equal to 3. We are getting thrice S, thrice P, thrice D. All S, P, D are subshells. Again, for the split of S, there is no splitting. S is S, but P is again splitted into 3 values, Px, Py, Pz, and D is splitted into 5 values, xy, yz, dx square, y square, dz square. And this further smaller splitting of the subshell is called orbital. Am I right? So these are the very simple concept of shell, subshell, orbital, electron. Train is a shell, each coach is subshell, each seats are of coach are orbitals, and each passengers in each seat is called electrons. So this is the very simple concept of shell, subshell, and orbital. I hope you have understood the concept of shell. Now my main point is to explain the shape of orbitals. Shape of orbital, the last part, shell, subshell, orbital, then electron. Bigger, smaller, smaller, smaller. So shape of orbital. Shape of orbital. Orbital. First of all, we'll assume S orbital and we'll see what is its shape. So at the very beginning, I told you the value of L is related to this. When L is equal to 0, it is S. L is equal to 1, it is P. L is equal to 2, it is D. L is equal to 3, it is F. Am I right? So for S orbital, what's the value of L? L must be equal to 0. For S orbital, L is equal to 0. Again, a bit earlier, we have shown that M is equal to minus L2 plus L. So the value of M is on value of L. So if L is equal to 0, minus 0 to plus 0, that is M is equal to 0. What does M signify? M signifies the orientation of the orbital in the space, in which way it is oriented. Hence, here value of M, it means no orientation. No orientation means directionless. 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 It has no direction, means it is spherical. S orbital, L is equal to 0, M is equal to 0, no orientation, no direction, means its shape is spherical like this. This is S orbital. Now, very often in the entrance exam or class exam, you are confused with one question. Note. These are the question very often asked in the entrance exams or also in the class exam regarding node. Now, what is node? Before giving, I have given you the shape of the s orbital, and now let me touch upon one of the very important fact regarding node. What is node? It is a space, it is in three-dimensional space where there is no possibility of finding electron. The space having zero possibility of finding electron. It is the space having zero possibility of finding electron is called node. Node is a place where there is no possibility of finding electron, means electron density is zero. Now, how is it possible there somewhere we will get electron possibility of finding electron possibility zero? We'll give some formula and we'll explain how, but what is its practical implication? Radial node is given by, for time being, you keep it in your mind, n minus l minus 1. Angular or planar node, plane, I will explain what is plane. XYZ is three-dimensional space, XY plane, YZ plane, ZX plane, that is plane. Planar node or angular node is given by L, value of L. What is total node? Planar node L, angular node L. What is planar node? Means in the plane XY plane, YZ plane, ZX plane, in any plane there is no possibility of finding any electron. What is radial node? Means in a spherical manner there is no possibility of finding the electron. This is a spherical area. If there is possibility of finding electron is nil from the center in a spherical way, that is called spherical radial node. Or say it is in this way, we have drawn in this way, and this is the place, this is the center where there is no possibility of finding electron, this. So this is a spherical or radial node. The node, the area in a circular manner, in a spherical manner from the center where there is no possibility, food is called radial. And planar means XY, YZ, ZX. In this place there is no possibility of finding this. And that is angular node, means if there is a plane, from the plane to the angle, if there is no possibility of finding electron, that is called angular node. So first of all, you keep it in your mind, the radial node, space where there is no possibility of finding electron, is called node. What is nodal plane? The plane where there is no possibility, XY, YZ, ZX, no possibility of finding electron, is called radial node. And what is planar node and radial node? In the spherical area, if there is possibility of finding electron, is not radial node. And what is total node? Total node is equal to n minus 1. Why? Because if radial node is this, and if angular node or planar node is equal to L, angular node is, number of angular nodes is only L. Keep it in your mind. This is very important. Planar node is equal to number of L. L will give you the angular node or L will give you the planar node. And radial and planar both will give you the total node. And this n minus L minus 1 plus L, is it not L? So this radial plus this planar or angular will give you the total node. Total node is equal to this minus plus L. N minus L minus 1 plus L is equal to n minus 1. So if we are asked to find total node, you just n minus 1. You are asked to find out radial node, n minus L minus 1. If you are asked to find out angular node equal to L, you are asked to find out planar node equal to L. So let us, why I have explained this one, let us first explain L is equal to 0 and whether there is any space in the 1s orbital. Say it is 1s. In the 1s orbital, are there any possibility of any node? And if there is possibility of node, let us check whether it is radial node or whether it is any other node. So let us first explain the total node in 1s orbital. When 1s orbital, total node, here n is equal to what? N is equal to 1. If you put the value of n is equal to 1, so 1 minus 1 equal to 0, means there is no such space inside it where there is possibility of finding electron is nil means it does not have any node at all. It does not have any node at all. We have tested with the formula n minus 1, where the value of 1s means n is equal to 1. Put the value of n, 1 minus 1 equal to 0. It doesn't have any node. Now again you see, for twice s, again n is equal to 2, and for s, l is equal to 0. For s, l is equal to 0, m is equal to 0, means again it is spherical. But this spherical shape size is a bit bigger than 1s, and there is one possibility of node. So this is twice s. How can I say there is one node and distinctly it is radial, not spherical way? How can I tell? So the value of n here is equal to 2. Let us test the formula total node is equal to n minus 1. So when we will put the value of n is equal to 2, 2 minus 1 is equal to 1, means here the total node is equal to 1 for twice orbital, that there has one node where there is no possibility of finding the electron, and that node is like this. Now whether this node is radial node, yes, this is radial node, because n minus 1 is equal to, if you put here in radial, so n minus l minus 1, n is equal to 2 for s orbital, l is equal to 0, minus 1 is equal to 0, minus 1 is equal to 0, 2 minus 1 is equal to 1. That is, this node is nothing but a radial node, because when you put the value of n in a radial node, we get it has given 1, means it has one node, and that node is nothing but a radial node. Now say whether there is any planar node. No, there is no planar node, because there is no plane, because here the value of l is equal to 0. When the value of l is equal to 0, so planar node is equal to l. So l is equal to 0 means it does not have any planar node. So it has 0 planar node, it has 1 radial node. Its total node n minus 1 is equal to 1. It has total 1 node, and total 1 node is nothing but a radial node. So today, due to the length of the class, I can't continue for explaining the shape of p and d orbital. In my next class, I will start with the shape of p and d orbital. Hope you have minutely followed the class. Thanks a lot for watching the class, and request you to subscribe the class to get further updated information in next class. Thanks a lot for watching the class.